Hi everyone, so in this video I'm going to talk about the selection sorting algorithm. In the previous video I just talked about the bubble sort algorithm, and now in this video I'm going to talk about selection sort algorithm. And in the upcoming videos also I will cover all the sorting algorithms from basic to advanced level. So let's get started. Okay, so let's start with the selection sort algorithm. So in the selection sort algorithm, of course, it is sorting algorithm, so it is used to arrange the list of elements in ascending or a descending order, right? So let's talk about selection sort, selection sort. So we have a list of elements. We have a list of elements, which is basically anything. It could be 4, 3, 5, 2, and 1. Suppose it is in any random list of elements. And so what happens in the selection sort? In the bubble sort, we take uh, two adjacent elements at a time, right? But in the selection sort, what do we do? We select an element and we put it in the correct place. That's why its name is selection sort, right? So what do we do in this step one? In the step one, we do the first element. Okay, we do the first element, and generally we compare it with the its next index. Compared to the next index, suppose we want to place the correct correct element in the first place. What do you put the correct element in the first place? What will do? Suppose we have a variable cd, like current item. Suppose we have, it can be any name. We have like cd. Okay, cd. Suppose the for now cd is 4. Current element is 4. In the second case, once 4, now we have to compare it in the next index. So what is the next index here? This next index is this one, 3, right? Next index is 3. So we know that the indexing is start from 0, right? In the array indexes start from 0, so it will be like 0, 1, 2, 3, and 4. So the zeroth element will compare with the first element. And we know, since we are suppose we are sorting it in the ascending order. That means the smaller elements are on the left hand side and the larger elements on the right hand side. So what is the condition we'll use here? So if so let's use some different color. Suppose if yep if there's the condition, if left hand side is generally left hand side is greater than uh, the right hand side, then what we'll do, we'll swipe the elements. So here, in this case, the left side element is greater than the right hand side. That means we have to swipe the elements now. So what we'll do in case of the swipe? So we'll just do now the element will become 3, 4, 5, 2, and 1. Basically, no, it's not like this. The element, generally it will take count. It will take count of this uh, 3, right? So basically, now 3 is smaller. If 3 is smaller, we don't generally uh, swap. What we'll do, we just change the cd. We just change the cd to the current element. Like the current element, if you see the arr I. Okay. Okay. So arr I. Okay. We change the current element to arr I. So it is updated, like and the condition is also true. Okay, so if the right hand side is uh, this, so we'll store it in the cd, the current element, like this is the new smallest element, you can say. So new element, so we will here store the right side of elements. So we store here the right side elements. Okay, the new right side element, which is the smaller one, if this condition gets valid. So the new thing will become, it will stay the same. So it became like 4, 3, 5, 2, and 1, and the cd will be updated to 3. Now the 4 will be compared with the 5. now 4 will be compared with the 5. Now 4, like the 5, so what we'll check actually, we'll check now with 3 because it is already updated. Now we'll check with 3. So the now the condition basically became now the condition will be basically CT. If CT is greater than, if CT is basically greater than, if CT is greater than right, then we'll update the CT to the right. Okay. So in this case, CT is basically this condition gets false actually. So here CT value is 3, here CT value is 3, and right's value is 5. So this condition gets false. That means it will stay as it is, and the CD also not get updated. So now like now wait, again it will stay as it is, 4 3 5 2 1, and it will be compared with 4 with 2. Now 2, here the 2, actually not the 4 with 2, it's actually CD with 2. Okay, so it will compare with CD with 2. It will be CD with 5, CD with 2, and so in this case 3 is less than 2, so this condition gets true. That means now CD will be updated to 2. Now CD will be updated to 2. Now again the loop will be executed, and it will be 4 3 5 2 1. Now again CD will be compared with the last item, which is basically 1. Compared to the last one, which is basically 1. Now 3 is less than 1, so this condition also gets true. This condition also gets true. So now CT will be updated. Now CT will be updated to 1. Now CT will be updated to 1, right? So this is the first loop. This is step 1. In the step 2, it will go to the next index. It will go to the 1, and it will compare like what is the correct position, what is the correct element for the index, uh, the position 2, like index 1. So here at the last it will swap the element. So the swap, like CD is 1, so it will put it in the first index. So the after the step 1, it will become 1 3 5 2 and 4. Then it will swap this with the first index. So 1 3 5 and 2 and 4. This is the first step. This is step 1. After step 1, this what we will get. So now the step 2, okay, so now the step 2, okay, just a second. Okay, in the step 2, we have the element 1 3 5 2 and 4, right? 1 3 5 2 and 4. 1 3 5 2 and 4 in the step 2. So in this case we'll take the, like, the indexes 1 0 1 2 3 and 4. So in this case we'll check the like first index. Here's the CT, as we have CT equal to 3, right? It will be first initialized with 3. So in the step 1, so like it will start with the first name, because first elements thing is just fixed. It gets the it's like minimum element to sort in a ascending order, right? This position is valid for this element. Now it will go to the next position, which is basically the index number 1. So it will genuinely again it will compare with the next index. So it will compare with the next index. So it will check is basically if 3 is greater than 5. So it says no, it is not, right? So it will stay as it is. So it will be 1 3 5 2 and 4 again. So CD also not will be updated because this condition gets false. Now actually this element will be compared with this. Is 3 is greater than 2. It says yes, its condition gets now true. So the CD will be updated. So the CD will be updated to 2. Okay. Now again will be 1, 3, 5, 2 and 4. So now CD, now it will compare with the CD because CD gets updated. First of all, CD is 3. So basically you can also say that it is comparing with the CD only, but the CD, but in the first case the CD and the indexed value is same. That's why we uh, write it like this. But in this case it is comparing the CD genuinely. So it is comparing with the CD with the 4, right? It is comparing with this. So if CD means if 2 is greater than 4, it says no, it is not. If this condition gets false. So now since all the checks are completed, now the this steps result will become after swapping, because we are at the end of the array, right? So in the index 2 will genuinely store 2. Basically we'll swap these two elements, we'll basically swap these two elements, because we are in the CD we have 2 and we are in the index number 1. We are searching for an element, like the valid element for index number 1. So it will swap these two elements, so it will become 1, 2, 5, 3 and 4. Okay, now in the step 3, what do we do? Step 3, and the step 3, okay, the step 3, we have 1, 2, 5, 3 and 4, the previous step, right? 1, 2, 5, 3 and 4, and we are at the index number 2 now. We are the index number 2. So the and so the CT will be, 5 for now, and generally it will now compare with its next index, like third index. This value is 3. So it will say if 5 is greater than 3, it says yep, that is true, right? So the CG's value will be updated, like CD's value is updated with 3, and yeah, and the next step will be, and next step means the next sub step you can say, will be executed. Now it will be 1, 2, 5, 3 and 4. Now it will compare with the CD. The next index will be compared to the CD. So it will compare the CD with 4. It will say if 4 is basically if CD means CD like 3 is greater than 4, it will say no, 3 is not greater than 4. It's false. Now since we are at the end of the index, so it will swap the where we are in the index 2 with the CD. 3 value where the index with 3 value, this one, on the third index we have the value 3, right? This is the value of the CD. So we'll swap these two elements. Now we'll swap these two elements. So what will become? It will become 1, 2, 3, 5 and 4, right? Now we're on the fourth step, step number 4. Step, okay, sorry. Okay, we have the step 4. Now the previous steps result is 1, 2, 3, 5 and 4. 1, 2, 3, 5 and 4, and we have an index. Now we are at the index of third, because in the previous step we have the index of 2. Now we are that index of third, 3, right? So we are here, and this value of CD is value of CD is basically 5. Okay, for now. So it will compare with its next element, next index actually. It will compare with the next element. So if it says if 5 is CD is greater than 4, right? If 5 is greater than 4, it says if 5 is greater than 4, it's true, right? That means CD will CD gets updated. The CD will get updated with 4. CD will get updated with 4, and yeah, and then basically we are the last index. Since we are the last index, we'll swap it, and there's nothing. We are genuinely at the basically at the last index. So we'll now swap. We'll do 1, 2, 3, 4 and 5, because it will swap this index with a 4, like this one. It will swap these two elements. 4. So this is now sorted. So this is now sorted, and we sort it with selection sort algorithm. Okay, and we sort it with selection sort algorithm. So that's the whole video, whole explanation of basically the selection sort. In a few minutes, we will see the core of this algorithm, and we'll see how to customize it, like in a dynamic input, like dynamic size of the array. So we'll see that. Before that, let's jump into the time complexity and the space complexity of this algorithm. Let's jump into the time complexity and space complexity. Okay, because that is an important aspect of any algorithm, right? We'll define this, how much time it takes, how much space is required for any algorithm to genuinely predict its efficiency or compare with the other algorithm, right? By the way, I'll be doing a separate video on this complexity part, because it is really a tedious topic, and many students don't know how to calculate the complexities of many algorithms, how to apply many formulas to calculate an algorithm. Like there's a master formula, and there's a other basically lots of formulas that you can use to calculate the time complexities easily. And I will be doing that in a, after completing this like playlist, which is on the all the basic solid algorithms. And then after completing like data structures, I'll be doing like the time complexities, and also the Git and GitHub tutorials I'll be doing. Okay, I'll be doing all the things in this channel actually. So let's talk about time complexity. Okay, time complexity. Time complexity. So what do you see? How many steps we required? We have a four elements, right? In the array, we have four elements in this case. So norm of elements, we have basically five elements. We have 1, 2, 3, 4, 5, right? Like this one, 1, 2, 3, 4, 5. And the number of steps we required, basically it takes is 4 steps. It's required, right? It requires 4 steps, and norm of steps requires 4 steps, and actually 1, 2, 3, and uh, the number of sub steps is required. Like in the step one, if you see in the step one, it requires 1, 2, 3, 4, 4 steps, right? Yeah, it's 4 steps. In the step 2, it takes 3 steps. In the step 3, it takes 2 steps, and in the step 4, it takes 1 step. So sub steps, norm of sub steps, actually it is um, a bit about 4 4 and four steps, first step, 3 steps, 2 steps, and 1 step. So how do we calculate this one? How do we calculate this one? 4, 3, 2, 1. Actually, it is when we are calculating it. When we are calculating means when we are writing this algorithm, it is actually n squared. Basically, we look at two loops, but this is decreasing. Since it is decreasing, but it still remains n. Basically, we have suppose n number of elements, and we have n minus 1 number of steps we require. But in the norm of sub steps, it's actually decreasing. You can first of all 4 and 3, 2, 1, or you can say 1 plus 3 plus 2 plus 4. That means 1 plus 3 plus okay, 1 plus 2. Okay, just to erase it, I'm writing it in the reverse order. Okay, 1, 2, 3, and 4, and here it will be 1, 2, 3, dot 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 dot, and it will be n minus 1. It will be n minus 1, right? So 1, 2, 3, and up to n minus 1. So actually, if we put the formula, what will become the summation formula. First element, there will be one formula, first element plus last element divided by 2, right? First element plus last element divided by 2, the summation formula. So what we will get, it will be n upon 2. It is possibly you get in the sequence series chapter. I think this one is the formula, right? Is n upon 2. And in the norm of steps, we get n minus 1. So we multiply this 2 because in each step, we have a sub step. So we have to multiply this. So the time complexity, or you can say total steps, or you can say total steps, basically we have to multiply this 2. That means n minus 1 with the n minus 2. So it became, it is n square upon 2 minus uh, n upon 2. So if it's a big O, like this is the time complexity. So like in case of the time complexity, and if you express in the big O notation, then we have to like we have to cut the less important terms. Like this is the less important term. That this is the less important term. Like we have to cut the constants and the less like important variables, like less power variable. If it is n squared, is n, right? It is less power variable than n square. So we have to cut this too. That means the context will become of n square. And into the space complexity, since we not used any auxiliary space, any extra space to short this algorithm in basically in the selection short, that's why the time complexity is constant. That means it is big of 1, right? The time complexity is basically big of 1. So this is the time complexity and space complexity. It is like same as the bubble short algorithm, but maybe you need it in some like in solving some problems which why we need to select something, and then we have to use it. Basically I'll be doing in a video where I'll be discussing about like how to select an algorithm for problems, and that'll be a separate video, so I'll not discuss it here. So okay, that's the whole explanation, including the time complexity and space complexity of the algorithm. And uh, let's now see the code for this algorithm. Okay, how to deal with the code. Okay, so here we are in the replit. So here we are doing in the our codes, and it will be stored for your reference if you want to come here and see the codes what are you doing in the YouTube channel. So you can do it here. You can see the codes, and soon I'll be sharing all the notes that are required, maybe here if it's possible, or in the GitHub. Uh, okay, so let's start with the code of the selection short algorithm. Now the CodaGo folder, we're in the CodaGo folder, and there's the shorting folder. And then one day ago, I have created the bubble short. If you didn't watch the, like the video of the bubble short, then you can just after completing this shorting lecture, you can go back to the bubble short lecture. And so let's create a new REPL here. Okay. Okay. REPL. Java. Java. Okay. How to create a REPL in this folder? Actually, I don't know. Create REPL. I think it will automatically done it for me. Right. So let's do selection short. Create REPL. Okay. Okay. So that's the, let's start with the selection shot. So let's take an array of elements like int arr. First of all, we're doing it through the fixed size, and then I'll change it to the dynamic size. Like if you get it given size of the array, and we'll take the inputs, and then it will sort the elements. So I'll do it later. First of all, I'm doing it with the fixed size, like 4, 2, 5, 1, and 3. It's going to be a random element. It's not the same as the where reading the explanation part. Like you're creating the list of elements. Creating the list of elements. By the way, do share this video with your friends, and do share it in the Twitter, LinkedIn, and if you can, basically if you learn in public, that would be great. You can take a snapshot of this video and share it in Twitter, LinkedIn, and sharing in public will help you a lot. And that will be also motivate me to make other videos and other topics, and I'll be doing in the future like lots of exciting things like short snippets, and I will create plans in mind. So if you support me, then I'll be motivated. That would be a great way to give back to me, and I don't need anything. I just need your support, and that is all for me. Okay, so okay, let's start with the code. So let's now like code for the selection shot algorithm. First of all, I will do the code and then I'll explain it. So int like 4, let's make an city like current term or whatever you want to say, and I'm not assigning with anything. It will be int I equals 0 dot length -1, because we are in the step, in the outer step where like we're doing in the 4, generally 4 step. It will be 4 n minus 1 step. That's why we are doing arr dot length -1. Right. And I'll be I plus plus. So now O and j equal to I plus 1. Its next element will be j's, then arr dot length I plus j plus plus actually j plus plus. So here we are cd. It's cd with arr dot I. And here we're giving a condition if arr I is not arr I, cd. If cd is greater than the right side elements like j, then we'll change cd with arr j, right? And now we're swapping. This is swapping condition. Swapping condition, and it'll be like, so now swapping condition, like swapping code, and it'll be like and basically we don't want to store it, like we need the index number, so it'll be I, and like it will be cd, and we are storing the index number. Okay, that will be help me to swap the values, because with the values we cannot swap, with the index number we can. That's why we are doing it. And we are cd, we are storing the value of j because it is index, storing j, and in temp equal to arr dot the error dot ct with the error of I, right? ct and the error of ct with the error of I, and error of I became equal to error of ct. Okay, so that thing, oh no, ct will be temp. Who already I already explained like the how the swapping condition works. Like okay, so if you didn't watch it, then like watch the bubble short video where I explain how this statements work to swap two values, right? Like we're swapping code for swapping for swapping uh, like ct and ith index actually. Okay, so that's the whole code. So now let's print it, displaying the elements, displaying the elements. 4 and I 0 is less than error dot length I plus plus, and will be to display will be system dot out dot print print will be arr I, just adding a little space to look it decent. Yep, so I think it should work. Yep, 1 2 3 4 5, there's a shorted one. Okay, so if you change the elements like with 10 7 10 comma 7 comma again 3, okay, double elements, so run it again, so it will give a shorted list. Yeah, it will be 1 2 3 3 4 5 7 10, so it gives a shorted list. So this is the whole thing, whole code of the bubble short. Now let's explain how it is working. So we have an array of elements, and here we have a ct to store the like selected elements, so the index of the selected elements actually, to store the like to store the index of the selected elements, selected element. Okay, so that's the variable is used, we are using it for. That is use case for this variable. And the code for the selection sort algorithm, this is the code, this is the main code why we're using. So what we are doing, we are iterating the I value from I equal to 0 at arr dot length minus 1. So what we are doing here, like if we're going in the this pad, writing pad, so we're seeing that we have a generally 5 elements and we are doing 4 steps, right? That means n minus 1 steps we are doing. Generally here we are doing n minus 1 step, right? That's why in the outer loop, what we are doing in the outer loop, we are generally doing arr dot length minus 1. But in the second step, what are we doing? If we have a, suppose we have a zeroth element, suppose we have a zeroth element, so why are we just starting the why we're comparing, actually we're comparing with the next element, next the like zeroth element, the one element, that means 0 plus 1 element. That's why we put the value say equal to I plus 1, and we like define ct equal to I, because first of all way we are running the step, the beginning of the step starts with the like initializing the ct with the that particular like that like index value, right? So that's why we are giving here ct equal to I, and here we are like giving a condition like here, while this condition, if ct is greater than right side of elements, then ct will be right. Okay, so here we're giving the same kind of code, same kind of condition actually. If AR of ct is greater than AR of j, and we're storing the index ct like jth index in the ct, and then after completing this thing, we are swapping the CT value with the ith index. That means if you with this index, they will swiping the CT value with the ith index. Okay, the index becomes 1, 3, 5, 2, and 4. If we are in the step 2, we're in the index 1, and if CT is 2, we're swapping this 3 and 2, right? So that's how it works, and here we are just printing it. So that's the whole thing of the bubble shot. And you can also calculate the time complexity by thinking like it is n step, right? This n steps. Like if you remove the -1 part, so it is basically approximately approx n steps, n steps. Okay, and it is also approximately, if you remove those parts, like it is decreasing those thoughts, then it is also approx n steps, right? It is also n steps. So if we multiply this two, we'll get n square, right? So the selection shot, and the selection shot is algorithm's time is n square only. So that is the case, and we are not using any extra, like extra variable, extra auxiliary space for storing any values for the sorting algorithm. That's why its space complexity is like big of 1, right? So time complexity, here writing its time complexity, time, like commenting it out, time complexity is big O of n square, and space complexity is big O of 1. Okay, that is the whole code of the selection short, and this like whole code will be in the description. The code's link in the description. You can refer to it anytime you want. So that's the code, and in the next video, like tomorrow, I'll be doing the video on insertion short. So stay tuned for that. And if you like the video, share it, like it, share it, and share it with your friends. And do like do learn in public with the hashtag learning with Ronak. So that would be great. That would be also make you like you will be sharing what you're learning, right? That'd be great for your career also, because what people will see that you're learning these things. So that will be increase your chances to to get spotted for something, like something. It can be going to an event, or joining a community, or contributing to a community. It would help a lot, right? So that is great uh, for you actually. So that's for today. Thank you for watching the video.